Okay, today we'll discuss about this topic, the path of a charged particle in a magnetic field. Right. So this is based on the Fleming's left-hand rule, which you already are very familiar with. Okay. So, this is the Fleming's left-hand rule where it says that the index finger shows the direction of the magnetic field, and the second finger shows the direction of the current, right? So when there are those two fields, magnetic field and the current, when they are perpendicular to each other, they will experience a upward force, okay, which it is represented by the thumb, right? Now, let me draw the magnetic field on the paper. Let's say this is a paper, let's say this is your question paper. So you can draw the magnetic field in this way. You can draw certain rows uh, of X letter. So this X letter with a number of rows represents the magnetic field. Okay. Remember, this is a magnetic field. Okay. And how is the direction? The direction is from north to south. That is, your outside is north pole. The inside of the paper is the south pole. That is, if you make the left hand rule using your hand, your palm, this index finger, this one, okay, is represents the magnetic field, isn't it? So it is from north to south. So outside is north, the inside is south. So if the question asks you what is the direction of the magnetic field, so you can write the direction of the magnetic field is towards the inside of the paper. Got it? Inside of the paper. Clear? So if they ask you about the direction of the magnetic field, you will write it is towards the inside of the paper, inwards of the paper, whatever. Right. Now let's talk about the path of the charged particles. Okay. Let's say there is a positive charge. There is a positive charge which goes inside the magnetic field in this direction, which is the same direction as of the index finger. Okay. Sorry, the second finger, the middle finger. Okay. So you have to uh, make out the answer using the Fleming's left hand rule. Let's say it goes inside directly. What will happen is it will experience a force and it will curve towards upward positive charge. Okay, right? It curves upwards and makes a circular path inside a magnetic field like this. Now, let's say we have a negative charge coming from the opposite direction. Why I'm telling you it's opposite direction? Because let's say we have a circuit or a wire connected to a battery. This is the positive terminal and this is the negative terminal. So how will the charges flow from positive to negative end in this direction? See, this is the same direction, isn't it? And this flow is called conventional flow, right? The other type of current flow is electron flow. So from where does the electron flow? From this terminal, from the negative terminal. It goes like this, okay? And it comes in the opposite direction with regards to, with respect to the positive charge, right? So when it comes like this, what will happen is, now based on the Fleming's left hand rule, it will bend towards downwards or it will go to the south, let's say. And again, it makes a circular path again, keeps moving in a circular path, right? So how would you find the direction of electron? The path of the electron, that is, you have to just flip your palm. You have to find the direction, the force of the force on the electron, right? So both will take a different direction, right? Right. So I think you have understood this concept. Now let us directly go to the question paper and see. Right. So let me take you to uh, June 2024 2 PR paper. The question is, yeah, here is the question. Next one. Yeah, see here. The diagram shows it is the eighth number question. The diagram shows the machine that can be used to measure the speed of fast moving protons. Proton is a positive charge. So when it enters into the hole, okay, it makes a circular path. Now this circular path where it is making is it is due to the magnetic field. Okay, right. So it makes a circular path and goes and it gets attracted to the negative charge plate because it's opposite charge. So they will get attracted. So they ask you a question, give a reason why the proton is attracted to the negative charge plate because they are opposite charges. Opposite charges they attract each other. That's what you will write. Okay. Second question is you are going to usually you are going to find the time. Okay, using the formula acceleration equals v minus u divided by t. Right. So okay. So our focus is the next question B1. It says the proton passes through a hole in a negative charge plate and enters an area where there is a magnetic field. The magnetic field exerts a force on the proton as shown in the diagram. This force causes the proton to flow a circular path without changing the speed. Give the direction of the magnetic field. Okay. So according to this diagram, you will find out the direction of the magnetic field. Right. So outside it is North Pole. So inside is South Pole. So the answer is yeah, inside the paper. The magnetic field, the direction of the magnetic field is inside the paper. Okay. So let's see the marking scheme. Yeah. Or you write inside the into the page. Okay. Got it? Right. Now let's go to the other question. This is uh, a different paper, Jan 2020 paper. Right. Question number 7. Yeah. Okay. Again, the similar type of question. It's about the motion of the path of the particles. The first subdivision 7A says describe how to use two permanent magnets to produce a magnetic field. You may draw a diagram to support your answer. Okay, so this is a usual answer you know very well. You will just have to draw two magnets, okay, with unlike poles very close to each other, and then you have to draw the magnetic field lines, uniform magnetic field, and you have to write that they are evenly, the magnetic field lines are evenly spaced, right? And they form this uniform magnetic field in this way, right? Now, next question is our focus. The diagram shows the proton moving in a circular path at a constant speed in a uniform magnetic field. So I already told you that when a charged particle enters a magnetic field, it takes a circular path. So that is why they have mentioned this here, circular path at the constant speed. Okay. This motion is similar to the movement of the planet in the solar system. Now, subdivision number 1, Roman number 1, draw an arrow to show the direction of the force on the proton. Now, you have to understand here that they are not asking the direction of the magnetic field. Instead, what are they asking? They are asking something else. The force of the force on the proton, isn't it? So you will have to imagine uh, that the proton is being pulled towards this point. So this point is nothing but the magnetic field line, just going like this. Okay. You don't have to draw the magnetic field lines. Okay. Just have to draw the arrow towards the center. Okay. So this shows that the magnetic field is pulling the proton towards it, right? And the question already mentions it is making a circular motion. It is rotating just like how a planet rotates around a star. Got it? Right. So this is, hold a second. Let me, Right. So this is a second question I just wanted to discuss. Okay. So coming back to our diagram here, yes. So you have to remember that when uh, any particle, okay, let's say it is a positive charge or negative charge, when it enters into the magnetic field, it experiences a force, okay, according to based on the Fleming's left hand rule. Okay, positive charges they will move upwards and they will make a circular path. Negative charges they will move downwards and then they will make a circular path similar to the positive charge. Okay. This the difference is that they will curve in a different opposite directions because they come you know and come inside the field in opposite directions. Okay. You can find the force, the direction of the force using the Fleming's left hand rule.